Can you hear me now? Okay, yeah, the mic itself was muted and I couldn't tell. So, all right. Hello, everybody. Welcome to final exam review. So sorry about the technical difficulties there. We're going to start with practice exam 1. So I can only see the solution page. So if I get a question, like the start of a question wrong, please tell me. I'm starting with number 1. So this is finding the indefinite integral of 4x over x squared plus 2. If anybody has any specific problems that they want to go over, I can quickly zoom ahead to those, but we'll just start with this since someone asked to go through the first practice exam. So to start with, we have the integral 4x over x squared plus 2. So the way that we're going to have to do this is using U-Substitution because we have x squared on the bottom, 4x on top. So in this case, we want to start with the x squared plus 2. So we're going to say u is equal to x squared plus 2. Take du is going to be the derivative of this, which is 2x dx. We follow with dx because since we're integrating with respect to x over here, we have to do dx every time we take derivative. My bad. So now, since we have 4x dx, what we need to do is figure out how to convert, well, effectively this over to that. And so one way you could do it is by just saying, well, if we have x dx, we divide both sides by 2. So du over 2 would equal x dx. And so the x dx here would become du over 2. And so we'd have 2 du. Or what you could do is multiply both of these by 2, and you'll find that the same thing happens. So that's 4x dx. So that turns into 2 du. Just like this, if we go through, we get 2 du again. And then of course the bottom just becomes u. So this becomes the integral of 2 over u du. And that becomes a very straightforward rule where we get 2 natural log of u and then plus c. Then we just substitute our u in and we get 2 natural log of x squared plus 2 plus c. And that's our final answer. Makes sense to everybody? I'm gonna assume yes unless someone says otherwise. Then do you want me to move on to number 2, or would you prefer me to go on to another question in this exam? Because this is kind of the very beginning of your semester, so I can understand if you guys need refreshers.
Number 2.
All right, number 2 it is. All right. So for number 2, move this up a little bit. Number 2, we have another indefinite integral. This time it's 1 over and x squared plus 3x minus 10. So this one is not going to be U-substitution. Instead, it's going to be partial fraction decomposition. So what we need to do here is convert this into multiple different fractions. We start by foiling out the bottom, or not foiling, but factoring the bottom. So since we have x squared plus 3x minus 10, we have to determine 2 numbers that's product is negative 10 and that their sum is 3. So first thing that comes to my mind when I see 10 is 5 and 2, because that's the only other factors aside from 1 and 10. So if we do 5 and 2, we have x blank 5 and x blank 2. The reason I'm leaving blanks here is because we need to figure the signs. Since this is negative, we have a positive and a negative. And then since we know that this b term is positive, we know that the larger term has to be plus, and the smaller term has to be minus. Because 5 minus 2 is 3, and 5 times -2 is -10. So that's a little trick there. If you have these polynomials, you can factor them out quite nicely by using those shortcuts. So now that we have this, we know that, okay, so it'd be 1 over x plus 5 and x minus 2 is equal to a over x plus 5 and then plus b over x minus 2. I don't know why we bothered putting parentheses there. Okay. So next thing we do is we multiply both sides by this right here. So multiply both sides by x plus 5 and x minus 2. So in this case, the x minus 2 here cancels, and we get x plus 5 multiplied by here. So x plus 5. And then here, the x plus 5 cancels, and we just get x minus 2 multiplied through here. So we get 1 is equal to ax minus 2a, and then plus bx plus 5b. So now from here, we need to set up a system of equations. Mind you, we only have one equation, so how do we do that? Well, I like to separate out by constants and x coefficients. So we have ax and bx, but we don't have an x over here. So what we can do is we can say this is 0x. So now we can separate these into two equations. We get 0x is equal to ax plus bx. And so what we get here is we simplify to a plus b is equal to 0. And then for the non-x terms, we just have 1. So we get 1 is equal to, then I like to order it so that I don't have negatives first. That's just my way of organizing things, minus 2a. So we have 1 is equal to 5b minus 2a, and a plus b is equal to 0. What we can do from there is substitute in order to solve for one of these. And so since we have a plus b here is equal to 0, we can say a is equal to negative b by subtracting b from both sides. Oh, I'm a little confused on how you get 0x. So 0x, this is just saying I'm adding 0 here. And the reason why I do that is so that this 1 isn't alone. And so I can separate these into an x, or all our x terms and all of our constants. So in this case, since we don't have an x term written over here, I just write the 0x to kind of show that it's there, but hidden. So this is still total 0, but it kind of, I was hoping that it would help kind of separate these for you guys if you've ever had trouble with that before. Does that make sense? Just going to confirm real quick. Okay. So then, so we were on to substituting a to negative b by solving this real quick. So since we know a is equal to negative b, we can change the a in here to negative b, and we get 1 is equal to 5b. Then since it's going to be minus 2 times negative b, we'll get plus 2b. So we get 1 equals 7b, and b is equal to 1/7. And now since we know b is equal to 1/7, we also know a is equal to negative 1/7 due to this relationship up here. think it's good to assume. Because yeah, why don't they have any pencil sharpeners anywhere? All right. So since we now know our A and B, we can then go back to our integral, this time using this form. So we'll have the integral, indefinite, of -1/7 and x plus 5 plus 1/7 x minus 2 dx. And we can look at each of these separately since it's addition. So the integral of just this one, since we have x plus 5 on the bottom, it's single degree, so this will be a natural log integral. And then the constant here we can just move out, so we get -1/7 natural log. Since there's the derivative of the inside x plus 5 is 1, we don't have to worry about U-substitution. So we get x plus 5 inside there. And then same thing for this one. You'll notice I haven't written the plus c yet, because we'll just wait until the end to write that. So we get 1/7 natural log x minus 2. And then finally plus c. So does that make sense to everybody? Yeah, quickly get a new pencil that's slightly more sharpened. That one's not sharpened.
Are you able to move the camera a little bit just so we can see the final answer?
Oh. Yeah. So,
Awesome.
right there. Oh, that's why it's glared. My pages are slightly growing up. So there you go. Everybody good? I assume probably yes, since it's been up here for a bit. Don't know when the recording will be available. Hopefully soon. You guys have your exam 2 days, right? All right. Is it safe to assume a plus b will always be 0? Not always, because sometimes let me go back to this. So in here, we just happen to have 1. Sometimes you may have an x term in there, like let's say we have x plus 2 up there instead. So if we have x plus 2, you have to, so if you have x plus 2, this equation right here would become x plus 2. So then we have effectively 1x is equal to ax plus bx. So this would become a plus b is equal to 1. Then you'd have to substitute in that. So it gets a little more complicated. But if you have just a constant up here, then a plus b will equal 0. Otherwise, you have to go through it again. And you might not know, but is this practice exam similar in difficulty to the actual one? I think this is actually, at least one of these is the exam from 2020. So probably pretty similar in difficulty. If it was pre-COVID, or if it was from a pre-COVID exam, it might be more likely that this is more difficult, but I'm not completely certain on that either. So I guess next we can go to number 3.
Have we done 1 and 2?
Oh wait, there was a B.
Yeah, they're asking, could we do 1B after this and then 2B?
Oh,
There's a B.
yeah, I definitely missed that. Okay, yeah, I see 1B and 2B now. Okay, my bad. I was just reading the first one and then skipping. Okay, so number 1b, because I forgot to do number 1b. So this, another indefinite integral going back to, oh, this is going to be integration by parts. I think that's what it's called. Yeah. I always forget vocab. I just know what to do at the time. So we got, yeah, x cosine of 2x. So in this case, we have to use our integral of u dv is equal to uv minus integral v du. So you'll either see Lipit, which is what I learned, or Liate, which I think most of you probably learned, because for whatever reason, I learned differently. So while these do look somewhat similar and also somewhat different, especially these E and T's being reversed, there's not much difference between them actually, and I'll show you why. So this is our logs. This is our inverse trig. So that would be like our arc cosine, arc cotangent, all that. And then, so this is polynomial, which I'm not going to write out fully, and this is algebraic, which are the exact same things. I just use slightly different words. And if there's time, go over number 9. Yes, I can do that after 1 and 2b. So then here we have exponential, exponential and trig. So the reason why these can be reversed is because exponentials and trigs tend to repeat themselves. So if we have e to the x, its integral and derivative are both e to the x. And if we have cosine, it goes from cosine to negative sine to negative cosine, back to sine, back to cosine. So we get a lot of repetition there. And so these are very interchangeable because they're both easy to integrate and derive. And that's kind of why we use, so this will always be, or these will be our u's, and these will be our v's in that order. So in this case, since we have a polynomial or algebraic as x, we'll have u equal x, and dv is going to equal cosine of 2x. So now from there, we can start filling out our integral here. So we have uv, so we need to solve for v, which is going to be the integral of this, which happens to be 1/2 sine 2x. Not negative because we're integrating rather than deriving. And then u, we find du is going to equal just dx, because integral or derivative of x is 1. So now we start filling out this, and we get the integral of x cosine 2x is equal to u times v, so 1/2 x sine 2x minus the integral of v, so minus 1/2 sine 2x, and then dx. So we just integrate this again, so 1/2, and since there's a 2 on the inside, we will get 1/2 x sine 2x. And then, so this is negative, since we're going from sine to cosine, we have to remember that the derivative of cosine is negative. So we'll actually get positive 1/4 cosine 2x. And lastly, plus c. Does that make sense to everybody? And how that was done? Everybody understand lipid versus Leate? Both are the same thing. I prefer lipid because it rolls off the tongue better for me. So no questions on that. So I guess I can move to 2B. Oh, these ones. These ones hurt me a little bit. So we got sine to the fifth, again, indefinite integral, and cosine to the third. So these typically come down to knowing which ones to group. Yep. So what we want to do here is, since we have an odd number of cosines, we want to convert a square or cosine squared. Okay, so we take, right? Yeah, okay. Okay, so what we do is we say, okay, we have cosine cubed becomes, so we're gonna do, make sure space in here. So we're going to do sine to the fifth x, cosine squared x, and then cosine x. The reason why we group this is because this right here can become 1 minus sine squared x. And then from there, we can say if sine, or if we say some term sine, so this is similar to U-substitution, we're just, so I like to use U, you might have seen W used a lot. Actually, let's just use W. I think W is what you use typically when it's not exactly U-substitution, but it kind of is. Still same idea. So we're going to say W is equal to sine of x. And then we have our derivative right here, because dW is going to equal cosine x dx. So now what we do is we replace all of our signs with w's, and we get the integral of w to the fifth times 1 minus w squared dw. And then this becomes rather straightforward integral. We just distribute w or w to the fifth then, and get the integral w to the fifth minus w to the seventh dw, which is equal to 1/6 w to the sixth, and then minus 1/8 w to the eighth plus c. And of course, we substitute these w's in for sine, and we get 1/6 sine to the sixth x minus 1/8 sine to the eighth x plus c. That's our final answer there. Looks like the glare is not hitting that one too hard. So that's 1 and 2b down. Someone asked to go over 9, so let's go do that real quick, since I prefer going over questions that people have. Okay, so this looks like our series. What exactly did this ask for? Okay, so we're given, switch to a new page. All right, number 9. So we'll have an A, B, and C. So start with A. you get sine of x over x. All right. Cool. Oh yeah, I get this now. Okay. So we got sine of x over x is equal to what Taylor series? So, so the way that we'll do this is you'll want to start with sine of x in this case. So sine of x or a Taylor series. So first derivative, and we're centering at x is equal to 0. So when we take just sine of 0, we get 0. Plus, and then first derivative would be cosine. So it'd be, so cosine of 0 is 1. And then we have x, and it'd be over 1 factorial. And then from there, we go back to 0 again because we're at negative sine. And then we're at negative cosine. So we get negative 1 x cubed this time because that was, so this is just x0, x1, x squared. So all of those are canceling because of the sine of 0. And then this would be over, so that would be 2 factorial, this would be 3 factorial. So knowing that, we can set up a pattern. And that will be by taking, so for sine of x, we get, let's see. So we get sine of x is equal to a summation. Going to be n equals, we want to start with 1. I think we want to start with 1. And we get negative 1 to the n, and then we can do just minus 1 here. So we start at positive. And then x to the n, or x the, it'd be 2n minus 1. Yeah, 2n minus 1 would be best. And that's because we're increasing in increments of 2. So we start at n equals 1, so 2 minus 1 is 1. When we get to 2, so it would be 2 times 2, 4, minus 1 is 3. So that follows that pattern. And then over 2n minus 1, just because of how I did it. So if you were to do 0, you would add 1 here. This would be plus 1 as well. I just happened to choose 1 as my start. So I guess it might be better to do that. 0. So just adding 1 to it, you just, to fix this slightly, 2n plus 1. So now when we have n equals 1, we get x is equal to 3. And that's plus 1 factorial. So now that we have sine of x, all that we have to do to fix this into sine of x over x is divide this by x, which happens to be quickly solved by just subtracting 1 from there. So we get x to 2n. And bam, we have that solved. So you do, I believe you have to do the first couple of terms for this solution. At least that's what it looks like for the rubric. So you'd start with n equals 0. So you get 1. And then next you subtract x squared over 3 factorial, yeah, plus x to the 4th over 5 factorial, and then plus dot 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 this term right here. to represent the nth term. Oh, y2. Yeah, you got it. Okay. Yeah, so I believe it's probably best if you start at n equals 0 for most Taylor series, because the 0th term is the original function solved at the center point. But yeah, so we can move on to B. So B is going to be quite similar. I guess instead of dividing by x, we're going to be doing something slightly different. So B is cosine of x squared. So we can use this format again for sine of x, just it's cosine starting. So cosine happens to be, we start at 1 because cosine of 0 is, so I'm going to do cosine of x is equal to 1, then plus 0 minus x squared over 2 factorial, and then plus x to the 4th over 4 factorial, so on and so forth. So plus dot, dot, dot. I guess I can just write the end term here. So it'd be -1 to the n, so that would be n equals 0 here. X to the 2n over 2n factorial. And so with that, if we substitute x squared in, so we get cosine of x squared. So we're just substituting in all of our x's for x squared. And we get 1 minus x to the 4th, 2 factorial, plus x to the 8th, 4 factorial. So this becomes, instead of 2n, we get 4n. And that would be the same as, so we have x to the 2n becoming x squared to the 2n. And since for powers, the product or the power rule for this would be a product of the two. So we get 4n instead. And I realized I picked this up from my chem class a long time ago, that you can take a 2 and make it into a 4 by just drawing a line through it. Like so, you got your 2 here, draw a line, you got a 4, a little curly. So for those of you that are lazy, use it in the future. So then we just have to fix this bit right here. So this is actually still 2n since it's cosine of x. But here we use -1 to the n, x to the 4n over 2n factorial. It should technically be in parentheses since you have to carry it through. So that's B, and then lastly C. Ooh, that's a fun one. Ooh, I don't have to deal with this one. Okay. I haven't seen this one before. All right, we got e to the x, and then plus e to the negative x over 2. So this one, so this is different from the other two, because the other two we were writing. So now we have to actually add 2 series. So first we take our e to the x. And this happens to give us, okay. So since e to the x we're centered around 0 again, we're just going to have the simple 1 plus x over 1 plus x squared over 2 factorial, because the e to the x just keeps repeating itself back to the e to the x. So that's, and this would be over 0 factorial plus x cubed, you get the point. Plus dot, dot, dot. Then e to the negative x, we start oscillating. So now instead we have 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial and plus dot dot dot. So since we divide both terms by 2. Oh, yeah, okay. So in this case, we'll see that these terms will cancel. These terms will cancel when we're adding them together. And so we're only left with the even powers. And since we're adding them together, which they're the same number, so we'll technically have 2 of this. So we get, so e to the x plus e to the negative x is going to be equal, so 2, but then we're dividing by 2, so it's back to 1. And then 2x squared over 2 factorial, but divided by 2 again, so it's just x squared over 2 factorial. And then we go to x to the 4th. We don't have to show that. So then this term right here, we'd be back to kind of a cosine just without the oscillating because it's constantly positive. So you get x to the 2n over 2n factorial. Does that make sense to everybody? I'll move this up so you don't get that glare. Well, no questions so far. Oh yeah, and this was part C. I guess I should write that. So you kind of skipped to number 9. Any other questions, or I can go back to number 3 if no one makes any suggestions. Let's see. And number 3 are improper integrals. Okay. No questions are made there. This is the only time I go through paper this fast. Homework assignments, I try to cram as much as I can possibly, but I understand that students are reading my papers here. All right. Okay, so we're gonna go on to number 3 then, since nobody made, well, nobody requested any specific problems. All right, so number 3, we start going into improper integrals. So we have the A part is the integral from 1 to infinity of 1 over x dx. So what we do immediately is we set this up as a limit. So we have the limit as b approaches infinity for the integral 1 to b of 1 over x. So from here, what we do is we solve for the integral here. So we get the natural log of x, since this is just a very straightforward integral in this case. And then plus c, but we actually don't need to worry about that since this is a definite integral. Taking the limit, again, as b approaches infinity, ln of x, and then 1 to b. So then this is equal to, again, limit. I always get sick of writing the limits while doing these. So we do limit b approaches infinity of natural log of, so we start with the first term, b minus natural log of 1. So for those of you who know, natural log of 1 is just 0. And then natural log of b, well, we just have natural log of b. So we get 1 to infinity. It's going to equal the limit as b approaches infinity, the natural log of b. I don't know why I wrote a slanted infinity there. And well, what's the limit as natural log of b goes to infinity? Answer is infinity. So we know that we can't actually solve that integral. It's just going to be infinite in size. So it doesn't have a limit like some other functions. So next we go on to b. So, oh, yeah, this diverges. That's what I should say. I'm just trying to get another pencil because, man, I really should sharpen these more. I have so many pencils too. And of course, like, oh, that's a nice one. Why didn't I pick this one up the first time? Probably because I'm trying to save it for tomorrow when I had my exam. All right. So B is going to be, so this one doesn't use infinity as a bound. Instead, it uses one of the discontinuity points. So 0 to 2 of 1 over the 4th root. That's a nasty one. X minus 2. All right, so in this case, instead of the limit as b approaches infinity, we have the limit as b approaches 2. 0 to 1 over 4th root of x minus 2. So this one isn't the nicest integral to take in our heads right away. This one's just an identity, so that's why I didn't show work. But in this case, we have x minus 2 to the negative 1/4. We don't have to use U-substitution because the inside is, well, the inside derivative is just 1. So we just use the power rule, add 1 to the power, and we get 3/4. So we get x minus 2 to the 3/4. And then since this is the new power, we divide, we get 4/3 x minus 2 to the 3/4. So we have integral 0 to 2, 1 over 4th root x minus 2 dx is equal to the limit as b approaches 2 of 4/3 x minus 2 to the 3/4, evaluated from 0 to b. So we get 4/3 b minus 2 3/4. You can see this just fine. And then plus, or no, not plus. I did plus up here. No, I did minus. Okay, good. Wouldn't have mattered, but matters here. So minus 4/3 and then 0 minus 2. So negative 2 to the 3/4. Like, can we do that? Isn't that imaginary? I'm not wrong in saying that's imaginary, right?
No, it's real.
Oh,
It's
it
not square or it's
Oh, really? Huh. I thought it was any even root.
because it's 3/4. So it's Ah, my calculator says it's real.
It's real? Oh,
I'll do it. I'll double check.
make sure you have parentheses around that.
Okay, I'll fix that. Okay.
I was gonna say, either way, you use that as the answer. In this case, I'm looking at the key and like, okay, they don't seem to mind. So. Yeah, that's just weird. Okay. You won't always get an imaginary number. It's just in this case, you happen to get one. Doesn't really change how you solve it. So we have a limit as b approaches 2. So if we plug in 2 here, we don't get an undefined number. We get 2 minus 2, which is 0. So we get 0 minus 4/3 -2 to the 3/4. And that's as much as they write for the key, because that's technically the farthest you can get without simplifying to an imaginary number. Because yeah, this would be a -8 to the 4th root. Yeah, just if it's an even root, you can't take it of a negative number, because you can't have an even number of negatives multiplied together to get another negative. So yeah, this would be the final answer in this case. Also, they probably accept that for the most part if it's a non-calculator exam, which I believe these are all non-calculator, right? That's what I'm used to for calculus.
Yes, it's not calculated.
Yeah.
So why do we have to mess with the limits at all if we can integrate the 1 over the 4th root x minus 2? If we can do that.
Okay, so personally, the way that I really learned this was I didn't even bother writing the limit, but that's because technically you're just writing these limits down just to go back to not using the limit.
Yeah.
Down here. It's mostly for like kind of ease of reading, I guess. So in this case, because here it's undefined, if we plug in 2, we write this, so nothing's technically undefined. Oh wait, I just realized I have a 2 here instead of b. So here, nothing is technically undefined. Whereas here, if we were to plug in 2 right now, it'd be undefined. So it's kind of a standard to getting rid of that mishap, to write it like this instead of as it was originally written. And then you continue writing the limits here and then confirm that now you can actually plug it in without getting an undefined number, if that makes sense.
Right. But I mean, let's say I were to not use the limits, I'd still end up getting the 0 minus the same thing, correct?
Yeah. Yeah.
Okay. But you just do it so it's not undefined. I got you. Thank you.
Mhm. No problem. So we are nearing the end of this session, and we're going to be switching people soon. So they can cover the rest of this. Any last minute questions about what we went over? If not, you guys can take your 10-minute potty break and then come back here. And new people will be over to take over for us.
What exams do you guys do? 2?
Oh, yeah, we're doing the exam 1. We've done problem
2, 3, and
1 through 3, and then number 9.
Okay.
So,
Was 14 your max? Was that consistent? Or
Yeah,
yeah.
pretty much.
I wasn't really watching, so, because I was doing this. I saw we started at 10, or well, 8, I guess. All right. Gonna stop recording.